This is a waveform with a frequency of 1 Hz, and it takes 1 second for one complete cycle. So what electronic device can generate such a waveform? The answer is a crystal oscillator. This is a 32,768 Hz crystal oscillator, and we need to build a peripheral circuit around it, so that it can produce 32,768 cycles within 1 second. Since 32,768 is 2 to the power of 15, we can use a step-down frequency division method to divide 32,768 Hz down to 1 Hz. The key is how to perform the frequency division. Edge-triggered flip-flops can do this job very well. Here is its internal schematic, which is made up of logic gates. This is its circuit symbol, with the clock input and data input, and Q0 as its outputs. This is its function table. For example, if we input 1 into D, Q won't output anything until the clock rises, meaning that when the clock signal changes from 0 to 1, Q can then output 1, while Q0 outputs 0. The output of Q0 is always the opposite of the D input. Now, what happens if we connect the output of Q0 back to its D input? For instance, if we start with D input as 1, when the clock signal changes from 0 to 1, Q starts to output 1, and Q0 outputs 0. At this point, Q0 will feed this 0 back to the input. When the next clock rises, Q will output 0, and this process continues, causing its output to keep changing. However, the output waveform is half as dense as the clock input, thus achieving frequency division. For example, if the input is 2 Hz, then the output Q will be 1 Hz. So, when we connect 32,768 Hz to the input of the flip-flop, it can output a frequency of 16,384 Hz. Then we connect 15 D-type edge-triggered flip-flops, and it can output a fairly accurate 1 Hz frequency. In practical applications, we can use simple integrated circuits to achieve this, like the CD4260, combined with the 74HC74. The CD4260 is a 14-stage binary counter, which is essentially made up of 14 flip-flops, and it can be paired with a 32,768 Hz crystal oscillator. This results in a final frequency of 2 Hz, because it only has 14 flip-flops, but we need 15. That's where the 74HC74 comes in. It has 2 flip-flops inside, and we only need to use one of them, which allows us to convert 2 Hz into 1 Hz. Do you know of any other methods?